for the International Aviation Organization for the presentation. Fifth presentation on my list is on building a space factory in the Lagrange point L5 of the Earth-Moon system by the Observer for Space Renaissance International. You have the floor.
Thank you very much, Honorable Chair. And I also would like to thank everyone in the audience who is still here and watches my presentation. Next slide, please. What are the main tasks of a space factory? It can be summarized as follows: processing of lunar and asteroid material, collecting and processing orbital debris, which is about 8,000 metric tons in Earth orbit. Then the extraction of iron, aluminium, titanium, and other metals from lunar or asteroid ore. Then the production of building materials like steel bars, aluminium panels, tubes, etc., and propellant. And last not least, the transport of semi-finished or finished products to construction sites in the Lagrange points of Earth orbit. Next slide, please. Now the favorite locations for an initial space factory are the Lagrange points of the Earth-Moon system. There are 5 Lagrange points which provide an equilibrium between the gravity forces of Earth and Moon, especially in the points L4 and L5. An object remains in a stable position because there is a triangle between the object, the Earth, and the Moon. Building the first space factory, for example, in L5, will enable us to process material and produce goods in zero gravity. Unlike on Earth or on the Moon, solar power is available for 24 hours. Next slide, please. The industrialization of cislunar space will start with the mining of the Moon. The proposed Lagrange space factory will start with processing lunar material, especially the so-called regolith. To transport the raw material from the lunar surface to lunar orbit, an electromagnetic mass driver can be used. This technology was proposed by Gerald K. O'Neill in the 1970s. Subsequently, unmanned cargo ships will transport the material containers to L5. Next slide, please. Now, the most important minerals on the Moon for heavy industry are oxides of aluminium, iron, titanium, and chromium. Hydrogen and oxygen can be extracted by electrolysis and be used to produce rocket propellant in space. Furthermore, the lunar regolith contains a vast amount of helium-3, which is rare on Earth and can be used for future nuclear fusion reactors. As you see in the picture, we can gain hydrogen and oxygen by reduction from ilmenite. Now, an additional source of material will be also the recycling of orbital debris to clean up Earth orbit. Next slide, please. Now, in a second step, material from near-Earth asteroids will be processed in the Lagrange Space Factory. Besides all kinds of metals, including gold and platinum, some NEAs contain carbon, water ice, and also rare earth elements. Approximately 18,000 NEAs, near-Earth asteroids, of remarkable sizes have been detected so far, some of them crossing the Earth's orbit around the Sun. Next slide, please. Here you see the different kinds of near-Earth asteroids, which are called Amors, Athens, and Apollos, whereas the Athens and the Apollons are approaching Earth, whilst the Amors are beyond Earth's orbit around the Sun. Next slide, please. So the construction of a Lagrange space factory in L5. All elements of the LSF are modular and can be replaced in case of damage or material fatigue. In a phase 1, the structure starts with a rotating habitat for a crew of 48 persons, which you can see at the left side. The human crew is assisted by artificial intelligence and robots when building this first habitat. In a phase 2, a central construction axis is built which carries all wiring, installation tubes, and so on. In the phase 3, along the central construction axis, the non-rotating manufacturing modules and the solar power arrays are built. Due to its modular construction, the entire LSF structure can be extended along the central axis. Next slide, please. So you'll see on the left side a cross section, and on the right side a perspective view of the LSF, and the red cargo ship is docking on one of the modules of the industrial facility. Next slide, please. Yes, on this slide we can see the hierarchy in the L5 Lagrange Space Factory. Of course, on top of the hierarchy there is the human crew, which gives orders to artificial intelligence and controls robots and manufacturing. And at the end, there is industrial processing and manufacturing in zero gravity or microgravity in L5. And from L5, there is the transport of the material, for example, to L4 or to low Earth orbit. Next slide, please. To establish the proposed LSF space factory, some precursory steps are necessary within the next years. A new orbital station in low Earth orbit as a successor of the present ISS, preferably with simulated gravity, may be in the year 2035. then a manned lunar base with an electromagnetic mass driver, and then an Lagrange space factory first stage to process lunar material and orbital debris from Earth, which may be in the year approximately 2045. Then starting the mining of near-Earth asteroids may be in the year 2060, and then the LSF second stage to process asteroid material, which maybe start in the year 2065 or later. In the long run, the majority of mining and heavy industry could be shifted into space to minimize the pollution and climate warming on Earth. This needs a new level of international cooperation and peaceful coexistence of all humans on Earth. Next slide, please. I thank you for your attention. Thank you.
I thank the distinguished observer from Space Renaissance International for the presentation. Distinguished delegate.